risk difference. We'll start off with the other names. You've got risk difference and rate difference. You can use risks or rates. Use them interchangeably, exactly the same methodology, so don't worry about that. Just for risk difference, you use risks. Rate differences, you use rates. So, what is it? You are essentially talking about the extra risk, and that's by taking out the innate risk in the non-exposed. Because you're still getting cases in the non-exposed. So you're showing how much excess risk you're getting by being exposed to whatever exposure you're actually measuring. So it's technically the true risk of that additional exposure. So the calculation here is R1 minus R0. That's risk or rate in the exposed minus the risk or rate in the non-exposed. So let's give you an example. We've got two areas, Area A and Area B. Area A is exposed to bad drinking water. Area B is not exposed to said bad drinking water. Now you will note that the people who are not exposed to the bad drinking water, they've still got cholera cases. They've still got the cases that are... So we're essentially trying to find out what the difference is between the two numbers. So we find out our risk per one person first. Chuck in our R1 and R0 on the side there. Plug this in. I'm going to color code them from now on. R1 will be red, the exposed will be red, and the non-exposed will be green. Okay? So then we plug in the numbers, get our result, 0.06486. But what does this number mean? So we're essentially cancelling out the risk in the non-exposed to go and get the true risk of the whatever exposure it is, the exposure. So we can count this as people in Area A, or the exposed site, have 6.5 additional cases per 100 people compared with people in Area B, the non-exposed. So here's our 0.06486, or times it by 100, 6.5, or 6 per 100, or 6.5%. So you can use either of them. It's best not to use the percentage because they're normally reserved for relative risks or risk ratios, but still works. So use them how you wish, I think. Let's go and give... So this is an example of when the exposure is bad. Now, you've got our exposed, actually has a higher risk. Again, exposed with higher risk. But what about if the exposure is actually good? And we flip these things around. Chuck in our number there. Now, the R1 and R0 on the side there has to be flipped around, because the exposure, as you'll see, shows a 0.04. So risk per one person, so that's less than the non-exposed. Okay, so that's a good thing. Being exposed to whatever it is seemingly good. So let's plug in the numbers. We'll color code them for you, and we'll plug in the numbers. The result is a negative number. Now, do not fear the negative numbers. They're not always indicative of you doing something wrong. It is essentially showing that there's a negative relationship. That's it. So let's have a look about what it means, and let's interpret it a little bit. Let's times it by 100 to go and get a bigger, chunkier number, so negative 6.48. So you have a 6.5% reduction in risk of the outcome, i.e. cholera, when associated with the exposure compared with the non-exposed. That's with the percentage, which best not to use, but this is a little bit better. B. People with the exposure have 6.5 less cases, i.e. the outcome, per 100 people compared with the non-exposed. So do not fear the negative numbers, it just shows a negative relationship. That's all it shows. So that is risk difference. Let's move on to risk difference in percent.